Now we look at this region R below the x-axis, enclosed by the curve y equals to f of x. The x-axis and the lines x equals to a and x equals to b. So how are we going to find this area of region R? So the concept is very simple, like what you have learned earlier. What we can do is, this function y equals to fx are going to reflect, so you'll get this graph here. So essentially the equation of this graph has to be y equals to negative of fx. So this concept you have learned in your year 1 work. So now this part here that I'm going to shade in red, do you agree that it has the same area as that of the region R? So obviously it has to be the same area. So recall that what we have learned in the earlier section, to find the area under this graph, what I can do is integrate from a to b, in this case, the negative of fx. Because essentially I'm looking at this particular graph, the area under that graph, dx, which is equivalent to negative integrate from a to b fx dx. So that's the reason why the area of region R is equivalent to the negative of integral from a to b fx dx, which explains this part. Right, please note that if you are integrating fx directly, and the portion of fx is actually below the x-axis, then what you're going to have is a negative value. Alright, let's look at example 7. Sketch the graph of y equals to x multiplied by x minus 1. This one shouldn't have any issue because you have a GC to help you, or you can base on your O-level understanding to sketch out this graph. Okay, hence, using the graph itself, find the area of the region enclosed by the graph, the x-axis, and between x equals 0 and x equals 3. So x equals to 0 is right here, the y-axis. X equals 3, probably somewhere here. Right, although this is not drawn to scale, so let's treat this as 3 somewhere here. So essentially, where is the area that we want to find? So if this is 3, then what I want to find is this area here and this area here in green. Right, let me ask you one question. Think about it. To find the area of this red part and the green part, can I actually integrate from 0 to 3 of the function itself, dx? Okay, the answer is no. Why is it not possible for us to do it this way? Because this red shaded part is actually below the x-axis. So recall that if I have a region below the x-axis, I have to put a negative in front of the function. So in other words, this will not work. So what we can do now is, we find the red shaded part and the green shaded part separately. So for the red shaded part, I'm going to use red color. Okay, the red shaded part, it has to be integration from 0 to 1 of the negative of the function. So essentially a negative I can bring outside. I'll have x minus 1 dx, that's the red part. As for the green part, I will add on, integrate from 1 to 3 In this case, I do not have to put a negative in front because essentially the shaded part here is actually above the x-axis. So integrate from 1 to 3 of the original function dx. So evaluating this whole chunk here will lead us to the answer. So for the red shaded part here, we can integrate it manually since it's not that difficult. So this one I leave it to you. How do we actually use a GC to actually help us to find is what you have learned before. So you just need to go to our GC and key in alpha window, go to number 4, lower limit 0, upper limit 1, and the function is, remember, the negative x of bracket x minus 1 close bracket dx, and enter. Actually, by looking at this number here, we know that it can be written as a fraction. So we can go to math, number 1, and enter 1 over 6. So this is how the 1 over 6 is being obtained. And to find the area between x equals to 1 and x equals 3, doing the same way, I can get this answer. And finally, we just need to add up the answer of 1 over 6 and 14 over 3. This gives us the answer 29 over 6. There's a question here. Setting the lower limit as 0 and the upper limit as 3 in a single computation gives the answer 4.5, which is less than 29 over 6. Okay, why is it so? Actually, I've already explained it earlier, so just for you to copy down the answer. Because the integral 0 to 1 x minus 1 dx is negative. And so, when I integrate from 0 to 3, x of x minus 1 dx gives us 14 over 3 minus 1 over 6, which is 4.5. Instead of adding 1 over 6 to 14 over 3. Alright, for the earlier video that you have watched, we've discussed on how to find the area of region R enclosed by x equals h of y and the right side of the y-axis, the line y equals a and y equals b. Now we move on to look at the case when we have the region R enclosed by x equals h of y and the left side of the y-axis, the line y equals a and y equals b. So to find this region R, what I can do is I reflect this graph x equals h of y in the y-axis. So what I have now is something like this graph. And this region R is reflected to be here. Let's call it R prime. Okay, so this region R prime has the same area as that of the region of R. And this blue graph has the equation of x equals to negative of h of y. So to find the area of the region R is the same as finding the area of this yellow portion. So knowing the equation of this blue graph, I'm going to integrate from a to b of the function negative h of y dy, which is equivalent to negative integrate from a to b h y dy. And this explains why the area of region R is exactly this. Okay, also notice that if I integrate from a to b, h of y dy, it will give us a negative value. And that's the reason why we have a negative here to make it a positive value.